Hello, guys. Very good afternoon to all of you, and welcome to EduTechie once again. Today, we're going to look at a problem which is named by product of array except self. Now, by the name of this problem, you can easily feel that this problem looks very easy, right? Just multiply all the numbers with itself and then divide by the numbers that we want to exclude. That's it, right? I'm extremely sorry to say that's wrong because this division method will fail for a few of the test cases. And also you will see how the brute force method, or rather the method that we are just talking about, why it times out in certain cases. In the next few minutes, I will also show you that how we can optimize space. And if you stick to the end of this video, you'll be able to see that how we can come up with a different approach apart from the brute force solution, and also then how we can improve that solution even to come up with an even different approach so that we can optimize space, right? So without wasting further more time, let's jump onto the solution. So if you can see my screen, this is an array that is given to us, right? Now, what is product of array except self? So we are asked to return another array. Let's say this is our input array. This was our input array, right? All right. And this is the output array. So what will be the output array? So if except 1, what is the product of all the other numbers? It's 2 into 3, which is 6 into 4, 24, 120. So we have 120 here, right? We have 120 in this position. What's the next result? Except 2. What's the output of all the product of other numbers? 3 into 4 is 12, into 5 is 60. So we have 60 over here, right? So we have 60. Okay. What's the next number? Except 3, we have 2 into 1, which is 2, into 4, which is 8, into 5, which is 40. Okay, fantastic. We have 40 here. What's the next number over here? Except 4, right? 2 into 1 is 2, into 3, 6, into 5 is 30, right? All right. And the final number of this particular output array is, if accepting 5, what is the product of all the other numbers? So the product of all the other numbers are 4 into 3 is 12, into 2 is 24. So that's our output array. That's what we want, right? Fantastic. So now the brute force solution. What is the brute force solution that we talked about? That, okay, accept this number. So if you take the product of all the numbers and simply start dividing the number. So let's say we want to exclude 1 and take the product of all other numbers. What do? We first take the product of all the numbers, right? Which is 1 into 2 into 3 into 4 into 5. And that is nothing but 120. So if we divide 120 by 1, we get 120. If we divide 120 by 2, we get 60. If we divide 120 by 3, we get 40. If we divide 120 by 4, we get 30. And finally, if we divide 120 by 5, we get 24. But when will this particular solution fail? This particular solution will fail. Let's imagine that you have a number, any number which is 0, right, in this input array. So dividing a number by 0 leads to not a number, which is infinite, right? So infinite is not accepted. So if we have any element in the input array which is 0, it can be more than one elements, of course, but any element which is 0, it will lead us to a wrong result, right? So that's one of the edge cases. Now, we all know that this integer has a range, right? Integer has a range. Well, how many bits does an integer have? It has 32 bits. And what is the range? For a signed integer, the range is minus 2 to the power 31 to the power 31 minus 1. Now imagine that these numbers are extremely large, right? Or this array is extremely large, right? So there might be a point in time where when we take the product of all the numbers as we discussed in this brute force solution, it might go out of this integer range. And if it goes out of this integer range, it will throw you an error. It will throw you an exception, right? So this method doesn't work. That is why this method doesn't work, because of these two classic edge cases. One edge case is if you have any element which is 0 in this particular input array, or if the numbers of this input array are too large, or if the input array is too large with a lot of numbers inside it, such that when we do the product of all the numbers in this input array, it exceeds the range of the integer, right? All right. So now we have to think of a better solution, right? What is a better solution? What can we think of? Okay, let's try to be very, very intuitive, right? Very, very intuitive. Let's say I'm trying to find the product of all the numbers of this array except 3. What do I do? What do I do? I take the product of 1, 2, 4, and 5, right? So what is the product of 1 and 2? So this is the product of 1 and 2. This is what I'm taking, right? Again, if I try to take the product of 4 and 5, this is the product of 4 and 5, correct? So it's very evident that I am trying to take every time a left product and every time a right product, right? So what is the product to the left of 3? What is the product to the to the right of 3, right? Similarly, if I try to take the product of 4, if I try to take all product of all the numbers except 4, again what I need to do, I need to take the product of all numbers to the left of 4 as well as the product of all numbers to the right of 4, right? Similarly, if I try to take the product of 2, product of all the numbers except 2, what do? I take the product of all numbers to the left of 2 and I try to take the product of all numbers to the right of 2, right? So these are the product of all numbers to the right of 2. Now, to do this, we also need to handle one particular case, right? What is that particular case? Let's say we start off with 1. We cannot start off with 1, right? Because there are no numbers to the left of 1. Also, we cannot start off with 5 because there are no numbers to the right of 5. So what do? Since we are taking the product of all numbers, we definitely don't want the product to be 0. So we consider that there is somewhere a 1 lies to the product to the left of 1 and a 1 lies, which is my right product, to the right of 5, right? So I start off my solution with a left product of 0. Of 0 means left product of this 1, the first number in the array, as 1, and the right product of the last number in the array, which is nums.length minus 1, to be 1 again, right? That is how we do the solution. And once we take that, what we do next is pretty simple. We take two arrays, right? One is our left product array. So let's consider this to be left product array. And then what do? And we take one more product array, which is our right product array, right? So this is our right product array. Fantastic. So let's try to take this product arrays and see what it comes up to, right? So if we try to take the left product array, as I already discussed before, that there is nothing to the left of the first element of this array. So we consider the product array or the left product array in the 0th index to be 1, right? Now we start our iteration from the first number of this array, which is 2 in this case, right? What is the product to the left of it? We already had a left product array. So this product, whatever is present here in the array, into the number. But what is the number here? In nums of 0 is 1. So 1 into 1 will give us 1. What is the product to the left of 3? It is of course the product that we have already evaluated to the left of 3 into the number to the left of 3, which is 2. So 1 into 2 will give us 2, right? Again, what is the left product of the number 4? The left product of the number 4 will be the product that we have evaluated until now, which is 2, into the number which is at the left of 4, which is 3. So 3 into 2 is 6, right? Again, going back to the last number, what is the left product of the number 5? Left product of the number 5 is going to be the product that we have already evaluated until now into the number to the left of 5, which is 4. So 6 into 4 will give us 24, right? Okay. So we have evaluated the left product array. Now we are going to evaluate the right product array, right? As I already spoke before, that there are no numbers to the right of the last element of this array. So we considered the right product of 5 to be 1, right? Since there are no numbers. Since we're calculating product, we are not taking it as 0, we are taking it as 1. Now coming back to 4, what is the product to the right of 4? Of course, the product that has already been evaluated as 1 into the number which is at the right of 4, which is 5 into 1 is 5. Okay, fantastic. We take 5. What is the product to the right of 3 now? Product to the right of 3 is whatever we have evaluated until now, which is 5 into the number to the right of 3, which is 4. So 5 into 4 is 20. Awesome. 5 into 4 is 20. What is the number to what is the product to the right of 2? Product to the right of 2 is the product that has been evaluated until now, which is 20, into what has been evaluated to the into the number which is at the right of 2. What is the right of 2? 3. So 3 into 20 is 60. Okay, so we get 60. We put in 60 over here. And then finally, what is the product to the right of 1? The product that has already been evaluated until now, which is 60, into the number which is at the right of 1, which is 2. So 60 into 2 is 120. So we get 120 over here. Now what we do? Now we simply run a for loop and we try to evaluate the product of all the left product array and the right product array. So this will give us our output array. So what is our output array? So let's consider our output array in this case, right? So 1 into 120 is 120, of course. Then 1 into 60 is 60. All right, so this is 60. Okay, fantastic. 2 into 20 is 40. Okay, so let's write down 40. 6 into 5 is 30. So let's write down 30. And 1 into 24 is 24. So let's write down 24. Now, if we match the expected result with the actual result that we have got with this particular algorithm, is it matching? Is this particular array is matching with this particular array? Yes, it does, right? It does. So our solution works, right? Our solution works. Now let's quickly jump on and code this solution up. And then we'll evaluate the time complexity and the space complexity of this particular solution. I hope my IDE screen is already visible to you. And so let's try to code this solution up. So what did we do? We first took two arrays, right? One was our left product array. And what will be the length of this left product array? The length will be similar to the length of the original array, right? Again, we take a right product array. So let's take right product. Okay, let's follow camel case notations. Right product, and then what we do, this length is also similar. Both the lengths are similar to the length of the original array, as you can see from here, right? The left product array and the right product array, both of this length are similar to the input array length, right? So that's what we have done. Now what we are going to do, now we are, as we already spoke before, right, that the product to the left of the first element of the array is going to be 1. This is going to be 1, right? And then we are going to run our loop from the first element of this array, right? And first element of this array and try to evaluate what is the left product for every element of the array. What will be the left product for every element? So if we start from here, from 2, the left product, as we already discussed, it's the product that we have evaluated before. That is, if the left product of I should be equal to the left product of I minus 1 into the number to the left of the particular numbers, which will be nums of I minus 1, right? So we'll write left product of I should be equal to left product of I minus 1 into nums of I minus 1. All right. So we evaluated the left product. Now what we are going to do, now similarly, as I already spoke before, that the right product to the last element of this array, since there are no elements, right, to the right of the last element. So we take this particular value to be 1. So the right product to the right of the last element of there is 1. Now we start running our loop. From where do we start? We definitely start running our loop from nums.length minus 2. Nums.length minus 2. We go till 0. That is how our loop runs. And similarly here, our right product of I is of course going to be whatever we had evaluated before, which is definitely right product of right product of I plus 1, because our I is nums.length minus 2 and the product that we had evaluated before was nums.length minus 1. So it's right product of I plus 1 into nums of I plus 1 into the number which is at the right of that particular element, right? So these gives our both left product array and right product array. And now what did we do? We simply ran a loop starting from 0 till the end of this particular array, right, till the end of this particular array, and we started we are not taking a different resultant array because we don't want to unnecessarily take extra space, again extra space, because we have already taken a left product and a right product. So we will use this array nums that has been given to us as our resultant array. So we'll say nums of I is equal to left product of I into right product of I. Right? I hope this solution is completely clear to all of you. And what we do next is we're just going to return nums, right? So let's first test this out with the solution 1, 2, 3, 4, 5. What was the output that we are getting? 120, 60, 40, 30, 24. So let me run this particular problem. Let's see. Okay, so we get 120, 60, 40, 30, and 24. 120, 60, 40, 30, and 24. That's what we were expecting. Right. So if we go and try to evaluate this time complexity of this particular solution, what will be the time complexity of this? Let's call this approach 1. So what is the time complexity of this particular solution, guys? The time complexity of this particular solution will be, we are running one loop for evaluating the left product array. We are running another loop for evaluating the right product array, right? And then we are running another loop to evaluate the resultant array, which is the left product of I into right product of I, right? So basically we are taking 3 for loops here. But the for loops are definitely not nested. So we are going to write O of n plus O of n plus O of n plus O of n, which is going to be thrice O of n. And this is nothing but going to be equivalent to O of n, right? And where n is nothing, but the length of the input array, right? What is going to be a space complexity here? What would be our space complexity in this particular case? The space complexity is, of course, see, we are taking a left product array and then we are taking a right product array. So it's going to be O of n plus O of n. But we are not taking extra spaces here to calculate the resultant array because we already spoke that we are going to just take nums, right? So in this case, our space complexity becomes O of n plus O of n. So one O of n is for evaluation of the left product array, and one O of n is for the evaluation of the right product array, which is equal to twice O of n, and that is equivalent to O of n in big O notation, right? And I already spoke what is n over here, right? N is nothing but the length of the input array. So that's the first approach, right? But don't you think that we are unnecessarily taking more space in this particular solution? Because we are evaluating it with a left product array and a right product array. Imagine that the input array is huge. Input array is extremely large. So the input array is extremely large. Can you see from this solution that what will O of n become? So to evaluate O of n, will need already a lot of extra spaces in the memory. Now on top of that, we are again taking O of n solution, right? So that is going to hurt our memory. That is going to hurt our memory. Don't you think so? So let's try to think that what other approach can we take, right? What other approach can we take to solve this problem? All right. So let's see. Let's first see. Okay. So this left product array that we have evaluated, if we call this as our result array, right? If this left product array is nothing but it becomes our result array, how does it look like, right? So let's call this as our result array, right? So this result array will have the same logic, right? Have the same logic, and it will have the same numbers, of course. So it will have 1, comma 1, comma 2, comma 6, comma 24. Now, for the right product array, when we are evaluating the right product array, right? What are we doing? Instead of taking this array, instead of taking a brand new array, whose length is equal to the length of the given array, right? We can just take a variable. Let's say that this variable is right product, right? Let's say that this variable is right product. And we evaluate this variable as 1 initially. Because why? Because when we started off, I already said that there is no number to the right of the last element of the array, and hence we have to take it as 1, right? So that is what we are taking right product to be initially. Now what we do? Now when we try to let's run a loop from the end of the result array or the end of the input array till here. So let's start from 5 till 1. Let's start evaluating from here. So what do we do? In the first case, we just have to form our result array. So result array already we have 24. So we have the left product array already present here. Now if we can simply multiply 24 into our right product, it will give us 24, right? It will give us 24. So this output will become 24. This is going to become 24 here, right? And next time when we do the next case, what should be our right product? Our right product should be updated to 5 because that's what we have in our right product array, right? It should be updated to 5. So we simply, in the next iteration, we do right product is equals to right product into nums of I. So if we do right product is equals to 1 into 5, then our right product next time becomes 5. and simply again we multiply 5 with 6, so that gives us 30. This gives us 30, right? Again, what we do, we change our right product. We change our right product to right product into nums of I, which is 3 now, which is 4 now. Sorry, so right product will become 4 into 5, which is 20. So 20 into 2 will give us 40. So right product will become 20 here. 20 into 2 will give us 40. So we'll evaluate this as 40, right? We simply do right product into nums of I. When we do right product into nums of I, we already did, right? So when we see here that our result was 24. So 24 into 1 was giving us 24. And then we update our right product to 5. So in the next case, it's going to be 6 into 5, which is 30. We update our right product in again into right product into nums of I. What is our and we similarly keep on continuing to do that until we get the entire array, right? So in this case, how it helps us, how this helps us, so we simply remove this particular left product. We simply remove this particular the right product array, right? And instead of left product, we are just saying that this is result, right? So we are doing result. Here also we are doing it as a result. This is also result. And now when we come to this section, we don't need to take another array over here because we simply remove that. We'll say that int right product equal to 1. We just take a variable as we discussed. And we start running our loop from the end of the array to the beginning of the array. And this time what we are going to do, we are going to evaluate our result, right? So result was already 24, which is the left product array. What we have in left product array, right? In this particular example, now the resultant array, nums of I, if we run our loop from the end of this particular input array to the beginning of the array, what is result of I? Result of I will be 24, right? So result of I, but what we need 24 into 1, which is our result. Which is our result, right? 24 into 1. And this right product is 1, nothing but right product, right? So what do we do? Result of I is equals to result of I into right product. That is what we do. And every time what we are going to do when we are going to go to the next iteration, we are going to update our right product from right product to right product into nums of I, because next time when we go, we have to multiply 6 with this 5 that we had in our array. How will we get 5? We'll get 5 when we multiply this 5 of the input array with our right product, which is 1. So what we are going to do is right product has to be updated to right product into nums of I, right? Nums of I. So this is going to give us the entire solution, and we also don't need this last loop here because we are already calculating result and we are simply going to return result from here, and that's it. So now if we run our code and see, we are getting the same output, but now what our time complexity becomes. So if we consider this to be approach 2, what does our time complexity become? The time complexity becomes O of n plus O of n. Can you see this? We are now not needing the final or the third loop that we were taking in the previous case, right? So we are just writing O of n plus O of n. So what is going to give us? It is going to give us twice O of n, which is still O of n. But imagine that the input array is too huge. It's extremely large. Then this helps because you're simply removing one O of n from here, and it extremely helps. Trust me, it extremely helps in real life situations. And space complexity, what does space complexity become? Instead of O of n, plus O of n, because we are taking a left product array and a right product array. Right now we have simply obliterated the right product array and we are just left with the left product array. When the left product array we are calculating as it as a result, and then we are using that result array to further do operations on that array and to get to the result, right? So we are not needing the right product array at all. So we took a result array, we considered or we evaluated all the left product, and then we took a right product which is equal to 1, and we simply evaluated our result again. And every time when we were actually evaluating our result, we were updating our right product because that's what we were doing in the previous case. But this same line, This line number 17 that we are doing, we were actually doing the same thing and storing it in a right product array, which is unnecessary. So here also we save one complete O of n. So imagine again, when the array size is extremely large, it actually helps us save a lot of memory space. So I hope that you like the solution to this problem. And if the solution to this problem is extremely clear to you, please like, comment, and subscribe our channel. And also the description, I already told in my last video that the first version of our EduTechie went live a few days ago, and it is live. Our contact number, our email ID is already given over there, so please feel free to contact us, guys. I'm pretty much sure that we are going to have a great discussion, and you will like it. You will of course like it. Please watch this video till the end, and please connect with us if you feel that it's necessary. We are always here to help you. Thank you so much. With this, I'll stop sharing my screen, and I'm going to stop this recording as well.